All right. Thank you all of you for joining today's session. Today is our first class, day one session, Azure Data Engineer. Uh, yeah, I just came from outside and I'm just not dressed properly. So, yeah, thank you all of you for joining today's session. Today is our first class. Some of you joined last Friday, more of an high level overview introductory class. But we have 3 4 new people who joined today just today. So I asked Vamshi just to summarize what we learned, what exactly an Azure engineer will be doing, a high level summary. Then Vamshi will navigate us to the most uh, very familiar platform, Azure platform. So what kind of features are there, and maybe tomorrow I think you all of you will be creating the accounts, and we just jump in like a war field, right, with weapons, and we don't waste any more time. Okay, thank you all of you for joining the session. Vamshi, over to you, sir.
Thank you, sir. Hello, everyone, and welcome to the day one session, guys.
Vamshi, let us go with a little bit of a slow pace. That should be fine. Thank you
Fine.
very much.
All right. Thank you. In the last session, we started a discussion with the traditional data processing. So, in the traditional data processing, we had some kind of concept called as data warehouse. And we have even discussed about what is a data warehouse. And again, so why data warehouse fails in some kind of aspects here. And then we have even discussed about the limitations of a data warehouse, and the solution to it is data lakes. So once again, let us go through these concepts here. Data warehouse architecture. See, data warehousing is some kind of concept which, the industry followed before it moved to the cloud kind of concept here. So that was purely some kind of on-premises solutions. Now I can speak about. All right. And then, so in a data warehouse, we follow some kind of ETL kind of architectures like extraction, transformation, and loading. So we have discussed that. See, we have even discussed this with some kind of retail example, some kind of Walmart example. So like we would be extracting data from different kinds of data sources, and then you would be integrating all those kind of data here in data staging. And then here is where you perform some kind of data cleaning process, and then you apply transformations on the data. So that means you transform the data as per the business needs and requirements. Then you finally load the data into this enterprise data warehouse. So this process is also called as ETL because you are extracting the data from different sources. You are then transforming the data and then finally loading the data. So ETL. So this process is referred to as ETL here. After loading the data into the data warehouse, generally we come up with some kind of end user reporting using some kind of BI tool, business intelligence tool. So that could be any kind of tool here. So we had a lot of tools. Now, you could even the popular kind of tool is Power BI and Tableau. So as of now, we are even using Power BI. And as part of our course, we'll also do a project on Power BI. Now, so here is where you extract some kind of data and then you analyze some kind of data with different visualizations here. You come up with some kind of reports, dashboards, everything in a visual format here. Fine. So this is the complete end-to-end kind of process of a data warehouse. Now, again, we have understood that data warehouse could handle only structured kind of data, structured data sources. It is well suited to run structured workloads. Structured workloads. Now, what do you mean by this? That means if you give it any kind of unstructured data or some kind of streaming data or some kind of semi-structured kind of data, it might not work well. Fine. So that is the concept here. Then what is the solution? So the solution is to move to the concept called as data lake here. Fine. So data lake. We then discussed what are the difference between a data warehouse and a data lake. Let me tell you what is this. Now, data lake has been designed in such a way that by looking at the limitations of data warehouse, data lake has been designed in such a way. First of all, data lake is some kind of cloud repository to store huge amounts of data. Then we have discussed that data lake can also help us store multiple data types here, meaning
Vamshi,
you can store the
Vamshi,
data in its.
sorry to interrupt you. Hello, Vamshi. Sorry
Yes.
to interrupt you. Your voice is breaking simultaneously.
Is it? What about now?
Can you now good? No, can you reiterate
No,
from the
it's
start?
not breaking. It's I can hear you well.
I
Yeah,
can
it's
hear
fine for
everything.
us too.
All right.
Fine.
Okay. Fine. Fine. So we were discussing about data lake here. So data lake is some kind of cloud repository which helps you to store different formats of data. So what are those formats is we can store some kind of data in a CSV format, Parquet format, some kind of big data, and again some kind of JSON format. So we'll also discuss about what are the different data types that a data engineer will be working. Then we also have discussed about the architecture which we'll be building as a lakehouse kind of concept here. We have even discussed about this one in a high level kind of way. I have told you what exactly this one is. Now they combine the best features of both of these platforms and then they come up with this kind of architecture, data lakehouse. So this is the complete review of the session that we had in the last demo. Fine. Now in today's session, I'll give you a much clear and again a concise explanation of all these kind of topics here. Introduction to Azure, Azure Data Fundamentals, and again Azure Data Engineering Services. Because as a data engineer, you need to first of all understand the Azure platform. So what is Azure platform? What exactly are the services that you will be using as a data engineer? And again, what are the data fundamentals? So let us dive into the Azure concepts here. To be frank, what is Azure if you ask me? Azure is a public cloud computing platform from Microsoft Corporation. Fine. Now we have different cloud vendors in the market here. So we have, we have different players, right? So we have AWS from Amazon, and again we have GCP from Google, and again so Azure from Microsoft. And again, Azure is one of the leading public cloud computing platforms right now in the market here, IT market. Of course, the first player to get launched in the market is AWS, but then Azure has taken the lead here. So in terms of data platform, so that means for data engineering, data analyst, and data scientist, machine learning. So these are some kind of services or domains. So where Azure is leading here. Now let us look at what is Azure. So even before we try to understand about Azure, so as I told you, Azure is some kind of public cloud computing platform. Then what happened before the cloud computing? How the organizations or the companies across the globe worked here. So let me give you a simple explanation about what is cloud and again what are the services here, because Azure offers you services from, it's a public cloud computing platform which offers solution in these service areas here, also called infrastructure as a solution. Then PaaS here, platform as a service here. Then we also have software as a service. Fine. So let me walk you down through these details here. This one. Fine. Let me go with any of these things. Right. Oh, not this one. Sorry. Yes. So what is this architecture? Let me tell you. So now this displays or this gives you the complete information or the differences between what is on premises and again the cloud models. Fine. Now even AWS, GCP and Azure, these are the three leading cloud service providers who offer solutions as part of these three domains here: infrastructure as a service, platform as a service, software as a service. But how you can understand, about these services. So even before you get to know about these services, you need to understand about what is on premises. Fine. Now, prior to cloud, that means even before we had the cloud concept here, companies or organizations across the globe worked, in on-premises kind of mode here. So what is on-premises? On-premises refers to as a physical setup. That means an organization would be having a physical setup in a location of their choice here. Then in that physical setup, what are the things that we find here? Now, in a physical location or a setup, right, we typically have some kind of server room, or people also call it as infra room, infrastructure room. In short, it is also called as infra room here. Now, what does it contain? Basically, in order to run any organization, right? So infrastructure is the first kind of service we need to have here, because first of all, we need to set up all the infrastructure. Only then we can set up the other kind of services on top of it. It's just like you first install some kind of OS, then you play with some kind of softwares in your laptop. It's that simple here. Fine. Now, in a physical on-premises setup, right, it is entirely our responsibility that we maintain this in physical infrastructure here. So we go with networking, and again, the different storage kind of things, the servers, the virtualization kind of softwares. On top of it, we go with different OS as per our needs here. So is it Windows or Linux or even Mac or something? And then we go with different kinds of application softwares here. Then we build some kind of applications, we test them, we deploy them. So this is what we do in a typical IT organization. So here, entire responsibility is on our hands here. That means we'll be managing, we will be configuring all the services here. So a production engineer or a support engineer will be working 24 by 7 round the clock here. And every organization has this kind of setup here. And again, see, the support engineers are also required to take the backups on a regular basis here. So every day they'll be taking some kind of backups and they'll be storing somewhere in the server here. Fine. So this is what happens in a physical setup. But again, let me tell you, so organizations followed this kind of concept, but again, this has some kind of limitations here, a lot of limitations. First of all, it is very tedious even for the bigger organizations to maintain this kind of infrastructure, because now what happens here is, as your data grows here or as your new clients get onboarded here, so you get some kind of new requirement. And again, as per the requirement, right, you need to go with new infrastructure setup here. Fine. So that means you are shelling out money from your own pocket here. All right. And this becomes, tedious for smaller companies here. Even the bigger companies would be, unbearable about this kind of cost here. So this is what the limitations are. And again, see, we also call something as the capital cost here, capital cost. So this is the main reason. So why companies are moving towards cloud kind of practices? Because what is capital cost? The cost that is incurred to run all the IT operations here. Now, what is IT operations? See, in IT operations, we have some kind of electricity, internet costs here, electricity costs here, and again the application costs here, the different setup kind of costs here, infrastructure setup costs here, and the wages or different things here. So that comes under capital costs here. And because of this main reason, this is the main reason that every organization is moving towards cloud here. Because see, what happens here is, now, this is fine if you have a limited set of data. But if you take the case of bigger organizations where they have large pools of data, or where they have a large client base here, so maintaining or managing this huge amounts of data will be a tedious task here. Every time they have to purchase a new server and they have to configure it and they have to maintain it round the clock 24 by 7, 365 days here. And it becomes a tedious task for each and every organization here. So likewise, there are few other kind of limitations as well in maintaining this one and in running this one. All right. Now, when cloud came into the concept, right, a cloud service provider is offering all these kind of solutions in a different services here. Now, what are these services? So we have something called as infrastructure as a service, then platform as a service, and then software as a service. Now, how can you understand this is, what is infrastructure here? As I told you, in order to run any kind of organization, the first thing that is required is the physical setup here. Fine. Now, this setup, if it is offered from the cloud service provider, right? So what you can do? You can just go with it. And again, on top of it, I mean, you can design your applications here. So the entire physical kind of setup is being managed by the cloud service provider. So that means this entire setup is being offered as a service here. So what are the services they offer here? Though, I mean, see, they give you some kind of networking devices, storage or servers or some kind of virtualization softwares. On top of it, you can go with the OS of your choice, and then you can build your applications. And this entire setup will be managed by the cloud service provider. You may go with, I mean, AWS, or you might be opting for Azure, or you might be opting for GCP as well. So the concept is the same thing, guys. So here, this infrastructure setup will be maintained and managed by the cloud service provider. So we are not configuring anything. We are not hosting anything. You're not even responsible to take the backups here. So the cloud service provider will be taking the backups here. Just you have to, I mean, build your models, test your models and deploy them. That itself is enough here. So if you have this kind of purpose here, then the other kind of service is platform as a service. So let me tell you, in infrastructure service, especially the admins, whether it is system admins or the DBAs or some people. So those people will be working a lot on this kind of service platform here. Then coming to the case of platform as a service is especially used for developers. It is built for developers here. Now, as a developer, I might be building different applications here. It might be an app, it might be a gaming development, or it can be some kind of software application development, or it can be any other kind of development here. Fine. Now, so whatever the software or whatever the kind of IDs or the platform that is required in order to build something and test and again deploy something, everything will be provided by the cloud service provider. You just have to maintain and manage your data here. So this is intended for developers here. And then the final thing is software as a service. Now, what is this one? See, software as a service is some kind of package solution. You just have to use that particular software in order to, depending upon your requirement here. Now, let me tell you, we are connected through Zoom. Fine. So we are connected to some kind of Zoom channel here, Zoom medium. Now, are we configuring it? No, right? We're just making use of that particular software here. Fine. In order to discuss here, in order to interact or in order to meet virtually. Fine. Now, this is a perfect example of software as a service kind of application because now I'm not hosting it, I'm not configuring it, but just I'm using it. Fine. So that is a software as a service kind of application. So depending upon the kind of, work you have or the kind of, service you want here, you can opt for this any particular service here, or as a whole, you can offer the entire cloud service kind of models here. So an organization, based upon their activity, they might be opting for any other kind of the service here. Fine. So this is what happens in a cloud models here. And the entire thing is managed and maintained by the cloud service provider. As an organization or as an individual, I just have to pay for the services that I'm using it. And on cloud, everything is pay as you go kind of model. Meaning, so based upon what services you are using, you have to pay only for those things. Yeah. So PaaS, let me tell you, some kind of developer applications like you might be going with some kind of SharePoint portal, and again some kind of some other kind of Java based applications or Python based applications where you require some kind of client server kind of roles, right? So those things comes under platform as a service kind of applications. And software as a service, so let me tell you, now your G Suite, Google Suite, so what does it contain? Let me show you something. See, if you go with this one, right? See, it contains all these kind of services here. Fine. It contains Gmail, it contains Drive, YouTube, Gemini, and again, Maps, Search, Calendar, News. See, let me tell you something. Are we hosting it? No, right? Are we configuring it here? No, right? We're just using this kind of service here. So this is, example of software as a service kind of application. So platform as a service is especially used by developers here. And then software as a service can be consumed by both developers as well as some kind of end users here. Yes, of course. So Microsoft Office Suite is also one kind of application here, comes under software as a service. Your Gmail is a perfect example of some kind of software as a service here. So likewise, if we take it, there are different examples here. So now, how can you understand this cloud model says what is on-premises is? Let me tell you something. You're purchasing a new car. So, I mean, see, you will be the owner of that particular car here. Fine. Then its maintenance, its fuel charges, and everything will be your, your responsibility. Now, otherwise, if I go with some kind of Uber or some kind of Ola, right? So what I can do, I can just simply book some kind of ride here. I can just go with select some kind of source and again some kind of destination. I can just make use of that service here. And again, based upon my source and destination, the kind of distance that I'm traveling, I just pay for the only that kind of service here. So you need to understand the cloud in the same kind of way here. So you would be paying for only those kind of services that you would be using in cloud models here. All the infrastructure kind of things comes under see this one. So it could be some kind of servers, some kind of networking, routers, modems, switches, and something, the gateways, LANs. Okay, so everything comes under this kind of example, infrastructure as a service here. All right. And as a data engineer, we'll be using these two services here, platform as a service and software as a service. Nowhere you will be given the chance to create something or configure something. Fine. In tomorrow's session, we'll discuss that one. So how the project is architected here in real world and what are the kind of roles or the permissions you will be having in order to create something. So we'll be discussing those things in tomorrow's session. Today, we'll discuss more of Azure. All right. So this is the introduction to Azure Cloud here. Then let me show you something. So I'll also guide you on how to create some kind of Azure portal. The first thing is you need to create Azure portal in order to practice all the data engineering concepts here. But I'll tell you, need not worry. Most probably tomorrow or day after tomorrow, I'll instruct you people to create this one. So, but one thing I'll let you know is, so Azure portal or Azure account comes up with a limited, validity here. So initially, when you create an Azure account, so it comes up with a $200 of free Azure credits here, which will be valid for 1 month here. Fine. And when you create your Azure account, so it looks something in this way. So this is called as Azure portal. Fine. Now, so what you can understand here is, so once you click on this ellipse button, so there is something called as all services. Click on this. So if you click on this, let me tell you something. Now, Azure is some kind of cloud platform which offers more than 200 plus different services in different categories. So when it comes to the case of AI and machine learning, you have this kind of services. But as I told you, data engineering, so we use the case of analytics here, analytics kind of models here or services. Now we'll be using some kind of services like data factory or data lake. And again, so Databricks here, Azure Databricks here, and again, Synapse or Power BI or even Fabric, Microsoft Fabric. All right. So these kind of services we'll be using. And then you could also see the different categories, the services that have been categorized into different categories here. Under the compute option, so this is where your admins will be using this kind of services here. So infrastructure as a service. Now we have discussed the same thing, right? Yeah, infrastructure as a service. Now these are the kind of services offered from Azure in order to maintain the infrastructure part here. So the admins might be working on the different services here. And then again, we have something called as platform as a service where the developers will be working on this kind of services here. Then we have something called containers. So containers nowadays, so as you people know, we are working in some kind of DevOps kind of models here. So where, we'll be continuously, we'll be developing something and we'll be testing something. So Azure also provides those kind of services as well. So we have separate services for DevOps here. And then coming to the case of databases, we have support with different kinds of databases. Azure provides you different databases integration so that you can work on cloud in a seamless kind of operations here. Then we have general, so where it, tells you something about your Azure portal management and again, hybrid plus multi-cloud. You can even work with multi-cloud applications here and identity. So this comes under the security kind of concept, integration with multiple other kind of services, Internet of Things, and again, management and governance. So this we'll be discussing in our Azure as well, in our course as well. And then again, migration. Migration is how you do the migration kind of concept here. So what is migration basically is, Migration. Have you ever heard about migration? What is migration? So migration is moving all the on-prem services to Azure cloud here. Azure cloud. Fine. So when we move all the services or all the infra part of the our on-premises services to Azure cloud here. So this is called as migration. Now, when it comes about the migration, right? There are two types here. So what you are migrating here, all the infra, I mean, kind of components or all only the databases here. So Azure also provides you with the different kinds of migration tools here. Of course, we do not require these services, but just to give you some kind of explanation about the Azure portal or the services, then again, we have something called as mixed reality. So mixed reality, you might have even heard about some kind of services like augmented reality, virtual reality kind of applications. So we can develop those kind of applications using this service here. Then monitor. Azure also provides you with some kind of monitoring kind of tools here where you can monitor your, your work here. That means, so you can monitor your pipelines in our Azure data engineering kind of services, right? We especially build the concept of data pipelines. So how do you monitor them? How do you check, so if your pipelines are working fine or if they're getting failure, so we can monitor everything here. Then again, as I told you, we have something called networking. So where again your admins will be working on this kind of services here. Again, the security, the cyber security and the Azure cloud security kind of concepts will be available as part of the services here. Then again, we have storage and then web and mobile here. Fine. So these are the different services that are categorized into different categories here. Now let me tell you. So we have discussed about like what is Azure, and again now let us discuss the concept of Azure data fundamentals here. Now what is data fundamentals? So data fundamentals is about learning and understanding the data platform on Azure. So we have a separate certification for this. So it is also called DP100 here, Azure Data Fundamentals. Fine. Let me tell you something about this one. See this one. Azure Data Fundamental. So this is a separate certification. And let me tell you, you people no need to write or attempt this certification. But again, I'll give you the concepts related to this one. Because though you might be working as a data engineer or some kind of data analyst or some kind of data scientist, right? You need to know about your Azure platform because see, you will be working with different services on Azure. So as a data engineer, it is essential that you understand the data platform first and the kind of services that you will be working. Now let us discuss about Azure Data Fundamentals. All right. Now, first of all, we'll start with the data basics here. So what are the data formats? Now, in the last session, that is in the demo session, we have discussed that data is classified into, structured, semi-structured, unstructured, and again, streaming kind of data. Now again, so structure is something where the data has some kind of predefined structure. For example, a SQL table. So where the data is stored in some kind of neatly defined rows and column format here. Then we have semi-structured, which resembles something in the format of structured and unstructured kind of things here. So, we have web pages that are the perfect examples of semi-structured data. Then we have unstructured data. So today, 80% of the data generation is into unstructured kind of format. I'm not telling this one. See, let me show you something. Structure was unstructured data. So this has been told by something called as Gartner. So Gartner is one of the popular IT research consulting firms across the globe here. Fine. So this has been estimated and again researched by Gartner here. Fine. So the unstructured data, see, it is about 80% of the data generation today is into unstructured kind of format. Now, what is unstructured? As the name itself tells you, data doesn't has any kind of structure here. But how does data look like then? So data, you can, see data which is stored in some kind of process files here, or some kind of spreadsheets here, or some kind of PDF documents. And now, see, look at this one. Now, this is some kind of notepad, so which we also call it as a text file. Fine. Now, this is a perfect example of a unstructured kind of data. So likewise, if you take it social media data, so that is an unstructured kind of example. And again, your email data, your messaging platforms. Today, we are dealing with n number of messaging platforms, WhatsApp, Telegram, and something. Fine, whatever it is. Again, IoT kind of data, social media data, as I told you. So again, anything, stock market data, streaming data, something, every data today is unstructured in nature because data is getting generated through different kinds of medium here. You play some kind of games online, data is getting generated. You search for something over Google search or different search engines, data is getting generated into unstructured kind of format. You book some kind of rides over Uber, Ola, so data is getting generated. You book some kind of foods over Uber Eats or something, so data is getting generated. Likewise, there are different examples, guys. So that is what they have given, like 80% of the data generation is into unstructured kind of data. And this is where there is a need for a data engineer here. Fine. Now, when the data was generated in this kind of format, that is structured format, so there was no problem. The data scientists or the machine learning people were happily working with this kind of data. But today, as I told you, we have numerous kinds of data types here, data formats here. So what are the different data formats? Let us try to understand here. Now, when it comes to the case of data storage, there are two different formats. So where the data is primarily stored here. So which we call it as a file as well as some kind of database. File. And again, we have something called as database. Now, what is a file? File is some kind of simple, it could be some kind of spreadsheet kind of, document here. So where the data can be maintained in different formats. So the most widely used formats in real world are CSV kind of file. Then we have some other kind of formats as well. So let us try to understand this. Exploring file storage. Now, what is this file storage? See, delimited text files here. What is the meaning of delimited here? Delimited means it is some kind of separator. So each and every field will be separated or data will be separated with some kind of delimiter here. It could be the most widely used kind of delimiter kind of file is a comma separated value file, also called CSV. Then again, today we are also working in some kind of automation environments where this kind of format, so we'll, play a lot here. JSON kind of format, Java, object notation here, JavaScript object notation. Then XML is the most older kind of format. Of course, we are not dealing with XML in nowadays here.
And
Again,
this is
sorry.
you are breaking in between.
I think I'm perfectly all right here. Please check from your end. My connection is stable, guys. Am I audible? Everyone can hear me, right?
Yes, Vamshi.
Right, thank you.
Yes, Vamshi.
Fine. Now again, we have something called binary large object. So where we can store some kind of data in the format of image, audio, video kind of format here. Fine. Because today data is getting generated into various kind of formats here. Fine. Not only text and numbers, we also have data, which is getting generated in the format of an image or some kind of audio or video kind of things here. Then we have some kind of optimized file formats. Now, what is optimized file formats is you can understand about big data. Now, in big data, we store huge amounts of data. Large volumes of data can be processed here. So what is the difference between CSV and some other kind of big data files is CSV can hold up to 1 million records here, not more than that one. Hardly 1 million plus records here. But if you go with an optimized file format, like a big data kind of format like Parquet, Avro, or ORC, especially Parquet. So Parquet can hold, 10 times more than the data that CSV holds here. 10 times more to CSV. Fine. Now you can imagine, right? So that means, so it is almost all 10 million plus here. Fine. So that is the kind of size it can hold here. Fine. And again, so it is optimized in nature because the data volumes is very huge. So these kind of files are optimized in nature. Optimized means they are compressed in nature. So meaning you can't read them directly. So we require some kind of database kind of service in order to read this kind of data. So we have Avro, we have ORC, and we have Parquet. So now let me tell you, as a data engineer, you'll be working I mean, mostly with CSV files and big data files like Parquet, and then JSON. Then we have text here, we have Excel. Fine. So these are the file formats here. When it comes to the case of databases, we have relational bases again, we have non-relational databases. Now you might be wondering, right? So what is non-relational database? Let me tell you. Now you know the concept of relational database. So it is some kind of SQL table. So the data which is stored in some kind of row and column kind of format. So we have both relational as well as non-relational. Again, when it comes to the case of databases, like we have both cloud as well as on-premises here. So we'll discuss that later. But what is non-relational data? Non-relational data is a special kind of database that we configure to store huge amounts of data. Again, especially we use this kind of data in big data formats here. So like, I mean, what are some of the best examples of non-relational databases are key value databases. So how does it look like? Look at this one, guys. Now you have some kind of key and there is some kind of value associated with this particular key. So that means it is 123. The key's number is 123. And again, this is some kind of value which is associated to this particular key here. So this is one example of a key value database. Then we have something called document database. So what is a document here? So document, you can understand it has some kind of a similar format to JSON. So how does a JSON look like? The data in a JSON look like is, so we have something in this way. For example, now if it is a table or a CSV file, right? You have something called employee ID, employee name, and then you have, location and then department. Fine. So, employee ID is one, employee name is A, and then we have location as New York, and then department is IT. For example, so this is just to give you some kind of a simple example. Now, again, this is some kind of format we have in a CSV or even some kind of table kind of format, SQL table. But again, if you look at the JSON, right, the same kind of format in a JSON, it looks something in this way. So we have employee ID and then colon, we have 1 year. So because employee ID is some kind of character, so we enclose them in quotes here. Then we have something, see, it actually has this kind of concept here. And then again, employee name here. Then we have A, because even this is some kind of character, we include them in quotes here. And then we have location. So we have something called as New York. And then we have department here. Department, and again we have IT. So this is how it looks like, guys. Fine. This is the kind of format we have in JSON. So it is also called as key value pair. So we have a similar kind of concept in Python as well. In Python, we have dictionary as some kind of data structure. So we have the similar kind of format. So meaning how you can understand is this entire thing is one particular record. So this, see, this one single kind of array. So this is one particular record here. If you compare it with a normal SQL table. Then again, we have something called column family databases. So what is column family databases? Now, column family databases comprises some kind of column, which is again divided into some sub columns here. If you look at this, there is some kind of customer kind of column, which has two sub columns here called name and address. So how you can understand this is normally if you relate it with some kind of SQL table, so customer name is a column and again customer address is again another column here. Similarly, product name and product price here are again some other kind of columns here. But again, column family databases contain some kind of columns which are again divided into some sub columns here. And graph databases. So what is graph database? Graph databases define some kind of relationship between different entities here. Meaning, now let us look at this example. So there are two workers here who are working in some kind of department called hardware. So Ben reports to Sue, and again, Sue is some kind of in charge for this department here. That means, so Ben is some kind of, Sue is superior to Ben here. Fine. So that means, see, there is some kind of relationship between these people here in this department. Fine. So graph databases are some kind of thing which is again used in some kind of machine learning and some other kind of concepts here. Of course, we do not require this kind of approach, but these are some kind of non-relational kind of databases. Now, Now that we have understood what is the relational database and non-relational databases, so how to handle this kind of data? Let me tell you something. When it comes to the case of databases, as I told you, we have both on-prem, that is on-premises, and then we also have cloud kind of databases. Again, see what is on-premises, where you have a physical setup. That means you download something, some kind of software, you configure it. That means you install it, and then you store some kind of data inside a database tables here, like Microsoft SQL Server. Then we have Oracle, we have Teradata, we have MySQL. So likewise, there are some various examples on this one. And when it comes to the case of cloud, so we have Azure. From Azure, we have Azure SQL database. Then we have from AWS, right? We have Amazon Redshift here. And again, Google BigQuery. And then Snowflake. So likewise, we have some other kind of cloud kind of databases as well. So, but here we'll be going with Azure platform. And again, it is one of the most widely used kind of databases on cloud. Fine. Now, so given some kind of data, some different kinds of data, how would you handle this? What are the services present on Azure which will help you to handle and store this kind of data? See, the concept I told you something. Let me again walk you down through this example. As a data engineer, you will be working with a wide variety kinds of data sources. See, as I told you, not only these kind of formats, see, you might be even, extracting data from some kind of web sources using the concept of APIs here, APIs. So we also work with APIs here. So as you see, we have some kind of different data sources here. So you have a database, you have a CSV file, you have a JSON, you have Parquet, you have APIs here, you have Excel. Of course, you have some other kind of formats as well. As a data engineer, your primary job is to extract this data and build the concept of something called as a data pipeline. Fine. So you ingest all this kind of data using this data pipeline. But where do you ingest? So you ingest and again you load them into something called as a data lake. Now we have understood the concept of a data lake here. So what is data lake and what does it help us to do here? Fine. So this concept here. Data lake is some kind of repository where it helps us to store the data in a native format. What do you mean by native format? Meaning data could be stored in its original format here. So if I have a Parquet file, I can still maintain it as a Parquet file. If I go with a CSV file, I can still load it as a CSV file. No need to convert the data to some kind of format, just like we do it in the case of data warehouse. So in the last demo session, I've also shown you by creating some kind of storage account. So where we have, where I've shown you, like you can maintain different data formats here. Well, APIs are application programming interfaces which help you to connect to different other kind of platforms here. You can extract the data from a web. Fine. So you have some kind of blog or some kind of website here. You can even extract the data from that one. Fine. All right. Now, let me tell you something. So again, we have discussed that, see, data warehouse is not a, viable solution here because we have discussed the limitations or the drawbacks of a data warehouse. So what are the drawbacks here? It can work only with structured kind of workloads here. So you can look at this figure here, guys. Can work only with structured data. So structured data, semi-structured, unstructured data, streaming data, everything is possible with the concept of data lake. Data lake, you can assume it to be some kind of cloud repository or some kind of cloud storage solution. Fine, cloud storage solution. Now, let us try to understand the different services of Azure. So what are the different Azure data services offered from the Azure cloud here? And what kind of services we will be dealing with. So now I'll tell you, a clear roadmap of this one. Now, the first service, let us try to understand about Azure SQL. So what is SQL? SQL is some kind of database service, so which helps you to store structured data. Now on Azure, we have three different kinds of SQL formats here. So you could opt for any kind of thing based upon your requirement. So as a data engineer, we'll be using this service here, Azure SQL database. Azure SQL managed instance will be generally, so this services will be used by developers here, database developers or some kind of development team here. And again, SQL virtual machine is used by your infra team. That means your admins here. Now, as a data engineers, we'll be using this one because see, what is the purpose that we'll be using a database for? To store the data. Fine. And then let me tell you guys, you could maintain the SQL database as a source or as a target here. So let me show you a simple use case. I'll also tell you what is this Azure Data Factory in a while. So this is just to give you a clear explanation of what you will be doing. So what you'll be working in real world scenarios. So understand that there is some kind of sales CSV file here or products.csv kind of file, which is stored in a blob storage. In the last demo session, we have even discussed like what is blob storage. Need not worry guys, how to create it in a detailed way. We'll also work on that one. So once we start with our actual sessions here, that means the practical kind of part here. So for as of now, you just understand that there is some kind of products.csv file which is stored in the blob storage here. So this is one kind of storage on Azure. Now, I just want to move this particular data to a table format here. So now in SQL, we can even see we can store the data in a table format here. And there is some kind of service called Azure Data Factory, which will help us to move this data here. So this is some kind of service where you build the concept of a data pipeline. So you generally move the data from this blob storage to Azure SQL database. Then, so here SQL database can act as some kind of target or it can even act as a source here. So likewise, Azure SQL database can be used in order to store the data. Data engineers may use Azure SQL database systems as sources for data pipelines that perform ETL operations to ingest the transactional data into an analytical system. Then data analysts might be using this service, Azure SQL databases, to host some kind of data. Fine. So there is difference. How does a data analyst work and what is the role of a data engineer? All right. Yes, Misha, we are going to have recordings here. Then, so you might have even, heard about some kind of open source relational databases, right? Like MySQL, MariaDB, Postgres, SQL, something. So we can also see, we also have support for all this kind of different relational databases on Azure cloud as well. And then what is Cosmos DB? So Cosmos DB is something. Now, if you remember, we have discussed about non-relational databases here. So what are they? Key value databases, column family databases, graph databases. We have just discussed before here. All right. Now, those kind of data could be used by this service here, Cosmos DB. Now, if you have such kind of data, you can maintain them in this kind of format here. And then, so now let me tell you what are the services as a data engineer will be using. Now ADE services. ADE services on Azure. Fine. So first thing is, let me tell you something about the storage, Azure storages. So when it comes to the case of Azure storages, because the primary thing is, first of all, you have to, store the data here. Then you can perform various different operations here. Fine. So we have something called Azure Blob Storage. Then we have something called Azure Data Lake Storage. So which is the primary kind of concept here, data lake. Data lake storage. Then we have something called Azure SQL database. So what is this one? So why we use these different kinds of databases here? Let me tell you now. Different kinds of storages here. Both blob storage and data lake storage are meant to store unstructured data. Fine, unstructured data. SQL database is something where you store some kind of structured data or relational data. So especially SQL database is used to store structured data. Fine. Store structured data. And then data lake is the primary kind of storage. Primary storage. Now this is used to store some kind of unstructured data. Unstructured data. Again, similarly, blob storage is also used to store some kind of unstructured kind of data. Fine. So when it comes to the case of data storage, we have the services. But again, let me tell you, there are three pillars of ADE. The three pillars of ADE. I call it as three pillars of ADE, Azure Data Engineering Services. So what are these services? We have something called Azure Data Factory. And then we have something called Azure Databricks here. And then we have something called Azure Synapse Analytics. Azure Synapse Analytics. Now let us discuss the concept of data factory. So what is Databricks here? And again, what is analytics here? Blob and data lake are both used to store unstructured data, but why we use both the concepts here is blob can also act as some kind of data backup services. Blob can be used as a data backup here. But the primary kind of data, data storage on Azure cloud is data lake here. So because as I told you, data lake can help you store different formats of data. Fine. So this is the primary storage. So blob storage, you can use it as a backup kind of service. Fine. So now let us try to understand what is Azure Data Factory. So three pillars of ADE, Azure Data Engineering, guys. ADE stands for Azure Data Engineering. Fine. Now Azure Data Factory. Or in short, it is also referred to as ADF. Fine. Now what is Azure Data Factory? So let me tell you, it is one of the cloud ETL service from Microsoft Azure. Fine. It is a cloud ETL service from Microsoft Azure. What is ETL? ETL stands for extraction, transformation, and loading. Fine. So it is a cloud ETL service from Microsoft Azure. And let me tell you, it is a no code or a code free kind of service. Code free service. Now, what is a code free service? Meaning no programming concept is required in order to build your pipelines here. Doesn't involve. So doesn't involve any programming logic. Fine. But again, what we, what we use it, we use it basically to build, data pipelines, build data pipelines. Fine, data pipelines here. Now, what is the usage of a data pipeline? As as I explained you here, data pipeline is some kind of, object here or some kind of cloud component. So where it helps you to move the data from different sources here. So you see, you have some kind of source which is stored in a blob storage. So it helps you to, extract the data from this storage and move to this particular database here. Likewise, there are different scenarios that we'll be working with. Fine. I'll help you with creating different scenarios, playing with different scenarios. So how you move the data between different services here. So this is a pipeline. And I think I've even, discussed about this kind of image here. So you have different data here. So what you do, you generally ingest all this kind of data using this pipeline service. So now, again, the concept of data pipeline is to ingest data. So what are this? This activity is also called as copy data activity, or data ingestion also people call it as, or data loading also people call it as data loading. Fine. Then, ADF can also use to, also helps us to transform the data. Transform data. Fine. And then it is also helps us to schedule the data pipelines here, schedule pipelines. Now, let's say I want to run my pipeline every Monday morning. Okay, so that it extracts the client data here. So then it runs some kind of pipeline. So we can even schedule the pipeline on a timely basis. So when you want to run that pipeline here. So let me tell you, ADF can act both as an ETL tool and again ELT tool as well. So both ETL and as well as ELT. Fine. So yes, Uma.
Vamsi, when you say transform data, is it like are we converting, the format like CSV into the required format, something like that? Or
Yes. So it is not only converting. See, now you have some kind of data. See, let me tell you, this is one such kind of example. All right. So the data is stored in a CSV format. It is
Hmm.
basically converting this data into something called as a table format. But generally,
Okay.
I mean, the meaning of transformation is not this. Transformation helps you to modify some kind of data. Like you want to
Okay.
filter some kind of data. You want to perform some kind of aggregation calculations on the data, like totals, averages, and something. Or you want to join some kind of data sources. Or you want to update some kind of data. Fine. So likewise, we have different examples here. So where we perform some kind of transformation kind of process. Fine.
And like we can transform and then we are loading into pipelines, right?
Yes, of course. Yeah.
Yep.
Yes, of course, Radhika. So this is a loading type, more of some kind of loading type here. Fine. So as I told you, ADF can help you to, work with all these kind of scenarios here. So first of all, it is a cloud ETL service from Microsoft Azure, and it is a no-code tool, meaning it is a code-free kind of service here. So no programming logic is involved to create the concept of a data pipeline. And the pipeline helps us to ingest some kind of data that is helps us to copy the data from different services here, and then we also transform the data. So that means EDF also helps us to transform some kind of data and helps us to schedule the data pipelines here. Fine. Now, yes, Uma.
Sorry to interrupt, Vamsi, but when you say that we are transforming data and we are not using any kind of programming logic, based
Mm.
on what, sorry if I'm lagging the technology or the terminology that I'm supposed to use here, based on what are we going to transform the data?
See, now, see, ADF gives you some kind of no code kind of tool, some kind of simple GUI kind of features here. Then you can transform the data as per your needs here. So we'll be working on them. I'll show you different scenarios, how you transform some kind of data. Fine. So wherever it is possible, we join some kind of data sources. We can even perform some kind of calculations on the data. So we have some kind of components inside this one, and it helps us to perform this kind of logic here.
Okay, Vamsi, thank you.
Without code, can you briefly tell us how? Now, what is a pipeline? So in the last demo session, I've shown you how to build a pipeline, right? So that is a kind of no code kind of service only. Have I written any programming logic there? No, right? I've simply shown you how you can create each and every service here. Then I've shown you like how you can, pick up some kind of data, that is extract some kind of data and load it into some other kind of service here. So there I've shown you like I've taken some kind of data from a blob and again load that data into a data lake. So that is purely some kind of node code kind of service here. Then we also have some kind of important service or a unified platform. So this is a unified platform for batch and stream jobs. Stream jobs. Now, what is a batch job or what is a stream job here? So what is a batch here? Let us try to understand. Now, batch in the sense, let me give you a simple vague example. So what is a batch here? Let's say you have some kind of 100,000 records with you, right? 100,000 records here. Now, you can load this 100,000 records in one single go, or you can even, I can even divide this data into multiple batches here. Because see, if I try to load this entire, 100,000 records, right, it might take some kind of time here. Fine, my pipeline will be slower because it is loading a large file here. So what I do in order to make it faster, right? So I divide this kind of data into multiple batches. Let's say, let me divide it into 10 batches. So each batch contains some kind of 10,000 records here, 10,000 records. So that I'll be having 10 batches here. So I can parallelly load the 10 batches here, or I can go with a sequential load. So there is some kind of process called as batch load and then sequential load. So we'll be working on this kind of process. What is batch load and what is sequential load? Batch load is like loading all the this 10 batches at the same time parallelly. Sequential load is one by one. That means you load the data one by one here. So we'll discuss more of this in ADF once we start with ADF. But let us try to understand that Azure Databricks is a unified platform for batch and stream jobs. Now, let me tell you, Azure Data Factory can help you perform batch loading. But when it comes to the case of streaming kind of load, right? So Azure Data Factory can't help you with this one because now what is the stream data? It is some kind of data which is compressed or which we can't understand directly by looking at that. Fine. Now you require some kind of specialized service. So here we will be going with Azure Databricks in order to process this kind of data, stream jobs here. Again, Azure Databricks also helps us to play with some kind of big data, process big data. Process big data. Now, big data, as I told you, the data, formats are different again. So we go with Parquet, we go with Havro, we go with some other kind of format. So here we'll be using some kind of, see, here it is purely some kind of programmatic kind of tool here. Programmatic tool. All right. So where we'll be using some kind of Azure PySpark here. So as I told you, so we go with the combination of Python and Apache Spark in order to process any kind of data. And let me tell you, the one biggest feature of Databricks or Azure PySpark, it can process any kind of data today. Fine. So there is no limitation for this one because we combine all the APIs of both the Python and Apache Spark here, and then we can play with any format of data. How it is done? So we'll discuss and while we move to Databricks kind of sessions here. Fine. So we have to write some kind of code for that one. And in order to understand this, we have a separate sessions on Python and Apache Spark here. So even before we discuss about Databricks, we'll be learning Python and Apache Spark here. So need not worry for this kind of things here. Processing is about transforming and then cleaning also. Data cleaning, data transformation, everything comes under processing. All right. So normally we call it as processing. Fine. And then again, see, when I speak about Databricks, right, in fact, I'm speaking about Apache PySpark here. And Apache PySpark is some kind of service which will help you to process any kind of data, whether it is a batch or streaming kind of data, or even it has some kind of inbuilt machine learning kind of services. So Databricks can be used for data engineering, data science here, and again, ML jobs. ML jobs. And we can even build the concept of a Delta platform. Delta platform, where I told you something about the Lakehouse kind of architecture. Fine, Lakehouse. Yes, of course, Pranita, you can understand that way. But again, EDF is not only for few amounts of data. Even you can play with large amounts of data. But the problem is, when it comes to the case of big data kind of formats, right? Especially Package file, Avro, or some other kind of formats, you cannot, read the data in a direct way. Meaning, what I mean to say is, now if you have a CSV file, let's say you have a CSV file, now you can open it and again you can understand the contents, what exactly it is. But Parquet isn't such way. So in order to process the Parquet file, right, we require some kind of Apache PySpark here. So we actually deal, Parquet or some kind of big data files normally on Databricks here. The real difference between ADF and Databricks is normally how we go in real world is all the structured data, we actually process it using some kind of ADF. So we perform data movement and structured data processing using ADF. All the files will be having different files, right? Like CSV, JSON, and again Parquet or some other kind of files here. So we generally process them on Databricks here. So this is how we do it. Fine. So you can understand the concept here once we move to Azure Data Factory. Fine. So this is the kind of platform we have, Azure Databricks here. Now let me show you some image. Look at this. So we'll try to understand the different differences between the different services here. Azure Data Factory, Databricks, and Synapse Analytics. Guys, I request your attention here. So just look at this one. First of all, what is a data factory? So we have discussed that data factory is some kind of cloud ETL service from Azure. So it is a managed service, easy to use, can be used to move data between different systems. ADF is best in terms of moving the data. Fine. So you have to understand why you're using this kind of service here. First of all, ADF is some kind of service which will help you to, perform data movement activities, like I shown you in this kind of way. So we have discussed this is one kind of data movement activity. So I'm moving the data from a blob storage to a SQL database. So this is one such kind of example. Then how you can understand the other things is, see, what are the weaknesses here? Limited data processing capabilities, not suitable for complex data analysis task here. So what is complex data analysis? Data, which is very huge here, or data which is some kind of streaming kind of data, or data which is some kind of big data kind of formats here. Fine. So all this kind of things, we cannot perform using ADF here. So we require some kind of specialized services for that one using Databricks here. So if you look at the use cases of ADF, right? Data movement and transformation, scheduling data pipelines. So this is what I told you, right? See, scheduling pipelines, transformation, that is transforming the data, and again, data movement activity, data ingestion. So all these activities we can perform with Data Factory. Now coming to the case of Azure Databricks, it is fully managed Apache Spark service, powerful data processing capabilities, good for machine learning. So because PySpark has the ability of machine learning kind of jobs here, running machine learning kind of jobs. So Databricks leverages the powerful features of Apache Spark on top of it. And again, see, looking at the features of Azure Databricks, right? It is not as easy to use as Azure Data Factory because it is a code environment. So you have to write some kind of PySpark code in order to process the data. And then when it comes to the case of use cases, Databricks can be used for data engineering, data science, and machine learning. So this is what I told you, data engineering, data science, and machine learning jobs here. And then you could also come up with a Lakehouse kind of platform that is an open source Delta platform here in Databricks. How to schedule in Databricks, that is a concept we'll be discussing later part. Okay, so as of now, leave it aside. At a time, one service to be used or all three together. I'll tell you, Surendra, so just pay your attention here. What happens here? Now again, see, we have discussed these two services now. So again, we have some other service called Azure Synapse Analytics. Now, what is this service? Let me tell you, Synapse is an proprietary tool of Microsoft, whereas Databricks is not a proprietary tool of Microsoft. That means it is not owned by Microsoft here. Databricks tool is a software provided from Databricks Corporation Inc. Fine. So this is some other kind of organization. So Azure is using Databricks in order to process big data. Fine. So this is what happens. So Azure pays for big data. All right. Azure has to pay for using Databricks here. Similarly, even if you go with AWS or GCP, even AWS, that is Amazon, and again Google will also have to be paying for using this kind of service here. So that is why they will charge you for using this kind of service here on Azure Cloud. But again, when it comes to the case of Synapse Analytics, right? Synapse Analytics is a unified platform. Again, I would tell you. So what is Synapse Analytics here is? So Synapse Analytics is some kind of unified platform again. Fine. See, it is the combination of your ADLS. So what is ADLS? Azure Data Lake Storage. And again, ADF, what is ADF? Azure Data Factory. And again, ADB, what is ADB? Azure Databricks here. So that means, so you could store the data, you could build, see, what are the services or what are the things that you can build using ADF, we can perform all those activities here as well. And again, the Databricks part as well, we can even perform here. But you might ask me some kind of question. If that is the case, right, then why do we have all these services here? Why can't we can even go with only this service, right? Why to use this kind of services? Now, let me tell you, Azure Synapse Analytics is very expensive compared to the other two tools here. That is the only limitation we have, from this kind of services here. Right. So because see, normally in a Databricks, when it comes to the case of Databricks, right, they only charge you for performing some kind of data operations. Fine. But in Synapse, right, they charge you for both storing the data as well as for data operations as well. So that is why it is very expensive. All right. And not every organization will be using this kind of service here, Synapse Analytics. Fine. Guys, I'll answer your questions. Please first try to understand what I'm saying. Fine. Please pay your attention here. I'll answer your questions. And now So if you ask me, out of 10 organizations, right, hardly 2 to 3 organizations use this kind of service because of its expensive kind of nature. But otherwise, this is a very, very best platform. Fine. In terms of working, right, this is very best platform. See, simultaneously, you can query the data, and again, you can even run some kind of Spark jobs on top of it. So that is this platform about. Fine. Now, let me tell you, because of this, because of this kind of limitation, Microsoft lost, clients here. All right, Microsoft lost some kind of clients here. And then what Microsoft thought was is, see, they want to come up with some kind of platform or some kind of service where they give you all this kind of components here. So you can so you can use data factory, you can even perform some kind of big data processing, or you can even build some kind of modern cloud data warehouse solutions here, a lakehouse kind of concept, everything you can process. So that is where they came up with some kind of concept called as Fabric Analytics, Microsoft Fabric. So now, what is this Microsoft Fabric? So it is some kind of end-to-end data engineering, data analytics, and data science platform for all analytics, all the data analytics here. Fine, data analytics. So what is this one? End-to-end data engineering, data analytics, and data science platform for all the data analytics jobs here. Let me show you what is this one. Let me tell you something. In detail explanation will, so we'll be having when we discuss about Fabric here. But as of now, I would tell you something. See, Fabric is some kind of end-to-end kind of service here, end-to-end platform. So you can understand it as some kind of package solution or some kind of, a big kind of software here. Okay. So where it will help you to perform the different data jobs here. So if you have the, task of building a pipeline, you can use this component here. And again, let me tell you the different services have been included in this Fabric as a components here. So these are workloads here. You see, we have data factory, we have Synapse data engineering, we have Synapse data science, Synapse data warehousing, Synapse real time analytics, Power BI, and again data activator. The concept here is to give all these services at a cheaper cost. And then the other thing is, see, first of all, their concept is to give you an end-to-end kind of service at a cheaper cost here. Cheaper cost. Fine. And then the other important concept is to not rely on any data vendors. All right, other than Microsoft. Fine. Now, if you see, let me tell you something. When it comes to the case of this data engineering, right? Synapse data engineering. So what is this one? So where you use some kind of PySpark jobs here. So before this one, we were using some kind of service called data bricks here. All right. In order to process this big data or batch and stream kind of jobs. Now everything you could perform here. So here using this service. And again, we also have real-time analytics where you can process the stream jobs here. Big data jobs, you can use this component here, Synapse data engineering. So when you have all these components, right? So what is the need of using a Databricks here? Because see, as I told you, when I speak about Databricks, I'm actually speaking about Azure PySpark here, not Databricks. Databricks cluster or Databricks runtime engine itself runs on Apache Spark here. Fine. That means Databricks is actually using the power of Apache Spark on top of its platform. That's it. Other than that one, there is no need of Databricks here. All right. So here the concept is to not to rely on any other kind of vendor except Microsoft here. So all of the components here are from Microsoft only. And then, so they are giving you with a cheaper cost here. And the storage concept is also very simple. Directly, you can store the data in terms of a lakehouse. So what is a lakehouse? We'll discuss that concept later here. So here the concept is called as a one lake, which is again a data lake here of Microsoft Fabric. Microsoft Fabric's data lake is called one lake. They have named it in that way. Fine. And then C is also giving you some kind of data warehousing. So where you can query large amounts of structured data. So if you have large amounts of structured data, instead of a database, you can configure it as a data warehouse, and then you can store the data here. You can query the data here. So if you have some kind of data, I mean, machine learning kind of jobs, you can use this kind of service. And again, you can use again some kind of Gen AI kind of services as well in order to, I mean, process the data. Then finally is also coming up with some kind of reporting kind of service here. So where you can build some kind of reports, dashboards, everything. So it is some kind of end-to-end kind of platform again. Fine. And data activator is where you can manage the data centrally in one lake here. Fine. So this is how, I mean, Microsoft Fabric is winning in this IT market now. So it is one of the most in-demandable tool right now in the market here, and it's growing. Its demand is growing like anything. So once it fully manages to, I mean, have the market share, right? You can see decline in Databricks here. Fine. Because see, every service is giving you. Fine. So there is no need to even rely on any other kind of third party service here. Fine. So I mean, see, every component is giving you. You can build a data pipeline. You can process big data kind of jobs here, streaming data, batch jobs, everything. You can even query some kind of structured data. You could also query some kind of unstructured kind of data. Everything you can do it. And finally, you can even visualize the data also. Fine. So that is end-to-end kind of platform. So this is what is called Microsoft Fabric. And now let me tell you, and he's also offering you this kind of service at a cheaper cost here. And when it comes to the case of certification, so we have something called as DP 700. So which is also called Fabric Data Engineer Associate. And one of our old students, I mean, so he has cleared this certification. Fine. And you can see that one in the group WhatsApp. Fine. So this certification. So when you want to go with some kind of certification, this is the certification that you need to go with. And we have this course here in our, I mean, courses. Okay. So in our data engineering course, we have this concepts here. All the Synapse, I mean, analytics components have been integrated into this Fabric Data Engineer Associate. Fine. So this is the entire services kind of thing. All right. Hope you got some kind of understanding. Now let me answer your queries here. So at a time, one service to be used or all the three together, Surendra, it depends upon the client requirements here. So most of the services, even see most of the architectures in real world, they're using the concept of, I mean, ADF and again Databricks here. So they're going with that one. So because no one is able to bear this Synapse kind of cost here, so they majorly they go with those kind of services. But now after Fabric, right, they're also, I mean, moving towards Fabric here. Fine. So can we say ADF is mainly for small jobs and ADB is for big jobs here? See, let me tell you, as I told you, the structure kind of workloads we generally process and transform using Data Factory. Data Factory is not only for small jobs, it is especially used for data movement kind of activities. See, you can move data, packet data also from different, I mean, services here. But when it comes with the case of big data processing, right? So that means large kind of data jobs processing, right? We go with Databricks. You need to understand in that way. So is this why Fabrics now exist here? See, as I told you, we have some kind of limitation of Synapse, which is very expensive. So they charge for both storing the data and again data operations here. Fine. So again, Microsoft rolled out this kind of product suite here. So with cheaper cost, and again is also giving you some end-to-end kind of components and services. So do you reckon companies are now moving away from Databricks to Fabric here? See, they are slowly migrating here, but there are still some kind of organizations who are still using some kind of Databricks kind of platform for different other kind of, job roles or something. Fine. But let me tell you, Fabric is gaining momentum. That means it is gaining importance here. So it is becoming a new trend here now in the job market, especially in terms of Azure data engineering services. Fine. So this is the complete end-to-end kind of thing. All right. So now let me show you the course contents. So what you will be learning as part of a course here. So Azure for the data engineer, this is just the basics here. So we have discussed today about what is on-premises and cloud kind of things here. So what are the services? And then the data engineering services on Azure. So we have ADLS, as I told you, Azure Data Lake Storage, Blob Storage, SQL database, data factory for pipelines, Databricks for big data kind of jobs here, Synapse Analytics, all right, and again, Microsoft Fabric. Then again, when it comes to the case of data storages on Azure, so we have different storages here. Yes, Arthur, I'll be sharing this one. Fine. So we have different storages here. So we have understood this one as well. And then when we move to the main concept that is Azure Data Factory, so how to build a pipeline, what are the different scenarios you'll be working as a data engineer tomorrow? So what kind of services you will be using, how the data, will be given to you, shared to you, or in some other kind of cases, everything. So end-to-end kind of pipeline designing will be doing with Azure Data Factory. So we'll be having, I'll also give you an introduction to what is Azure Data Factory in detail, again, when we move to this concept here. And again, as I told you, how to build the data pipeline, step by step, I'll tell you. Fine. So what is each and every component that is involved in creating a pipeline? So what are pipelines? And again, what are the different data ingestion methods? So these are very, very important, guys. Data ingestion methods. In interviews as well, they'll concentrate on this one. And again, in real world as well, you'll be working with this different data ingestion methods here. So because they'll be asking you what kind of data ingestion strategies you have used here. Fine. And then how to perform some kind of scheduling or triggering kind of activities. What is, how do you monitor the pipelines here? What is CI/CD kind of framework? Again, we'll discuss all those things here. And then, so once we complete Azure Data Factory, we'll be moving to Python. So we'll be learning Python here. And again, let me tell you guys, see the kind of Python that is required for data engineering, we'll be learning that one. Fine, not the entire Python suite here. And then after Python, we'll be moving ahead with Apache Spark here. So what is Apache Spark? How it is used in big data? And again, how can we work with Apache Spark here? So we'll be discussing each and everything here. Yes, assignments will also be shared to you on a timely basis. Fine. On each and every day, the session recording will be, I'll be uploading the session recording to the drive. You can watch it. And then I'll also share you some kind of data sets here so you can practice them and the assignments as well. From time to time, I'll give you certain assignments. You have to solve it. All right. So in Apache Spark, we'll be discussing what is RDD and again, what is data frame, the important concept, and then the concept of lazy evaluation or column manipulations, partitioning, and again, the different PySpark commands, and then how you can read and write the data. And again, the joins or the group by kind of concepts or again, the different concepts here. So we'll be discussing that. And once we are done with the Apache Spark here, then we'll be moving ahead with the Azure Databricks here. So how to work with Azure Databricks? Again, so we'll be working in detail, the concept of Delta Lake, Lakehouse kind of concept and everything. Then once we are done that one, so we'll be moving ahead with Microsoft Fabric here. What is Fabric platform? So how to work with the Fabric platform here. Then as I told you, while we discuss these services here, I'll be teaching you with different real-time ADE scenarios here, hands-on scenarios. Fine. So how to perform this one? Because these are some kind of things you'll be working in real world commonly. Fine. Synapse, now it is Fabric, guys. All right. Synapse, now it is Fabric here. So need not worry. It is Fabric. So we'll be learning Fabric here. Because learn the latest trend here. And again, after this one, we'll be discussing something about the data analytics here. So where we'll be working with Power BI. So what is data visualization? What is Power BI? How it is helpful? What is data modeling? What is DAX in Power BI? And again, what is Power Query Editor? So we'll be learning with projects here. Fine. And once it is done, coming to the kind of real-time projects here. So we'll be working with the data migration project, like how to migrate on-premises data from SQL Server to Azure Cloud here. Incremental loading using last modified date and time, and again CDC approach, because this one is the general kind of concept that you'll be working in real world. Data migration, incremental loading as a data engineer. SCD2 pipeline, and again end-to-end database project here, the medallion architecture, and again Microsoft Fabric project, and again Power BI project. So these kind of projects, you have to mention them in your CVs here. Fine. So directly you can mention them in your CVs.
Try again.
Then after this, once we are done with this course, right? So we'll be moving ahead with some kind of important sessions on your resume preparation or the interview stuff, how you need to handle the interviews. Fine. And then like what is regarding this the placements or even some kind of certifications as well. And again, your CV preparation, and again, your LinkedIn profile optimization. Fine. So this is the entire things that are offered end to end for you people. And then, as I told you, whenever you feel any kind of, doubts, or if you have any queries, you can reach out to me, or you can even post your queries in the group WhatsApp here.
Thank you, Vamshi. So we have one or two people raise their hands. We'll start
Yes.
with Pranita. Hi, Pranita.
Yeah. Hi, Lakshmi. Hi, Vamshi. I just have one question. Because in my project, we will be using Azure Synapse. We have a project. We are migrating Teradata, and we'll rebuild a created hub in Azure Synapse. So, learning Azure Data Factory and Azure Databricks, will that help together? Or do I need to practice separately for Synapse, or every environment and all the everything will be same in Synapse as Azure Data Factory? Because I just checked some kind of initial recording videos of previous videos. I saw both look similar. I don't see much difference, but what is the major difference in between the two? That's what I just want to check.
So the major difference is only one thing. So there in Synapse, so as I told you, they'll be charging you in terms of storing the data, and again in terms of data operations. But here they have completely removed the data, cost for data storages. And then the platforms are the both are the same thing here. So even in Fabric as well, you can simultaneously query the data, and again you can run some kind of Spark jobs on top of it. So once we get to Fabric platform, I'll also tell you the differences between what is Synapse and what is Fabric part here. So what are the differences they have put down here, so that you can be familiar with those kind of concepts here.
Okay, so everything infrastructure wise, if we look into the tool wise, tool will be same in all Synapse, Fabric, and everything. Everything will be same in all the three data engineering tools.
Synapse components have been integrated into Fabric here. So we have the same kind of concepts here.
Okay, yeah, thank you.
Arthur.
Yes.
Yeah, so since I think my question is kind of related to the previous question that she asked. So my company as well is using Synapse. So your best recommendation is like to maybe like suggest them to use Fabric, like in terms of reducing cost.
Yes, of course. Okay, so we'll do one thing. I'll also tell you one use case study on Synapse as well. Fine. So it will be comfortable for you people, right? So you can even understand so how Synapse works, and again what is Fabric here. We'll do that one. Not a problem.
Yeah, that would be helpful, please.
Yes.
Thank you.
Team, each and every session will be uploaded in the drive, so don't worry. So even if you miss, like somebody has messaged me why we are not stopping exactly at 1 hour. The sessions are for 1 hour and 1 hour 10 minutes here and there. With the question and answers, it may extend by 5-10 minutes here and there, but we are mindful on the time as well in the interest of everybody's time. We understand that we all have different commitments, but that's what I'm stressing is even if we miss 5 minutes here and there, you always have the live class recording as a backup, especially towards the end of the class every day, 5-10 minutes we have to dedicate for question and answers. We can't really blindly close the class just because we are just on the time. So appreciate your understanding, team. Thank you. Surendra, any questions?
Please, I have a
Yeah.
last question.
Yes, Arthur.
Is our instructor in our WhatsApp group?
Oh yes, of course, you can post the questions in the WhatsApp group. And yeah, he is our coach. Without instruction, how can we, like, he's the driver of the training. He's in the group.
Yeah, I'm just like, sometimes we can have some challenges at
No, you
work,
can
maybe
ask, you can post your
I'm not
questions.
there.
And we have to be mindful that he's also currently working in Microsoft and he's a research scientist actually. So, but as and when he gets time, you will get. Don't expect immediate kind of a response, but maybe as and when he find time. But definitely within few hours you will be getting it.
Hey, can I ask a question, please?
Yes.
Surendra, go
Yes.
ahead.
Hi, Vamshi, I have a question regarding the data is loading to the Azure in the blob master. That data should be like can be a real data or maybe like a stored data.
Yes,
Real
of
time.
course, it can be both here. Real data means it will be some kind of stream data.
stream data or from the like a real time, like a temperature value or something?
Yes, yes, of course.
And that one of the thing that there is the SQL DB. The SQL DB should be in the physical server or SQL DB should be in the Azure.
See, here we'll be going with Azure, that is cloud here. So we'll not be, storing anything in the physical servers here. That is not purely on premises here. So we'll be going with cloud.
So real time data can directly go to the cloud DB.
Yes. So even if we have some kind of data which is stored in on premises, so first as a data engineer, what you'll be doing is you'll be migrating that data to Azure SQL database. Then you'll be working on cloud here.
Like migrating the data from the physical SQL DB to the cloud DB.
Yes, yes, yes.
But the thing is, the physical DB is keep on extending by the real time values, keep on continuing adding the values, adding the tables. So do you think it's just migrating like as a real time thing or like continuously, or we have
Yes,
to
yes,
take?
of course we can do that one. So the concept you're asking is about incremental loading. Yes, of course we can do that one.
Yeah, okay. And regarding the APIs I have used before, the APIs are the one like which you can pull the data from one application source and put to the another application source, something like that.
Yes. So let's say you have some kind of data which is stored online through some kind of
Yeah,
web interface or something. So what you
yeah,
can do, you can pull the data from there. For example, there is some kind of data set available in data.world or Kaggle or something. And
yeah.
I just directly want to pull that data from that particular web to my data lake here. So you can even perform it using API.
Yeah, that thing I have used previously, like a generate a event in the program,
Mm.
and
Mm.
I used to push the data in the Insta Push app in the mobile. So that when
Mm.
I have used, but the thing is like that data, that data is can be directly go to the Azure SQL or not.
See, depends upon what kind of data format it is. If it is unstructured data, generally we'll be using data lake. If it is structured, we can load it in SQL database.
All right. Okay, all clear. Thank you.
Yeah.
Yeah, Radhika.
Uh, Vamshi, one quick question is like the blob storage and data lake both are storing data, right? So what
Hmm.
is the difference?
Good dot. Let me tell you, see, both helps you to store unstructured data and some other kind of non-relational data. But what is the difference is blob compared to data lake has some kind of limitation in terms of size, that is volume that you can store it. So that is the reason we especially use blob as a backup kind of service. So here the primary kind of storages will be moving every data to data lake because data lake has unlimited storage kind of volumes here. So that is the main difference.
Okay, okay. So blob is like a shorter version of the data storage,
Yeah.
but data lake is like a big, huge one, so that it can
Yes.
store multiple blob storage data into that,
Yes.
right?
Yes. Of course, you can
Oh,
understand that. Yes.
okay, okay. Thank you so much.
I have a question.
Yes, Arthur.
So let's say what is even like the main difference between AWS, like in terms of data engineering, and Azure? Like, what is the main difference?
There is no difference here. The only difference is Azure gives you cheaper cost here compared to AWS. So if I see if AWS is costing you, let's say $100 for some kind of data storage and data operations, Azure almost all charges you $20 to $30 here. So that is the wide
Oh,
reason why organizations prefer Azure. And again, in terms of different services, Azure is leading when it comes to the case of data platform.
okay. So let's say the transformation of data, for example, in AWS, do they still use the same tools? I guess it's different, right?
Yes. And again, see, not only that one, there are many differences here. And again, as you people know, once Microsoft has joined hands with OpenAI, right? So they have rolled out some kind of chat GPT kind of product here. So things got rapidly changed. Again, I regarding the AI services also, Azure is offering you some different leading services here. And again, I'm not telling you this one. Let me show you something. See, I hope you know Forbes, right? It's Forbes magazine, Forbes something. So they have
Yeah.
published this article here. So why Azure could take the cloud lead from Amazon AWS by 2026. So I advise all of you people to just go through this one. I even shared this in the group WhatsApp. In the last session, I've even shared this one. So just go through it and again, just read some about a bit of it, what exactly it is. So today, if you take it right, so there is some kind of tech wars going on, right? So the AI wars here, and again, see, everyone is, using this AI services, different AI services, and Azure is giving you some kind of cheaper solutions, and again, some different AI products here in terms of AI, Gen AI or something. And even in terms of the data platform, as I told you, you have a service for each and every kind of data problems here or issues here.
All right, team. Thank you very much. And yeah, we can ask any questions in the WhatsApp group. We need to jump into another meeting. Hope all of you enjoyed today's class. So in the interest of time, Vamshi, we can stop the recording.
Yes, yeah.
And I think AI group is also waiting, Vamshi.
Yes, yeah.
Yeah, right. Yeah, sure.